All right. Hey, good afternoon, everybody. My name is Gundersen from Mapbox. Earlier this week, we announced our Unity integration, bringing maps and location directly into Unity. I thought it would be good to just kind of give a sense of why we're doing this. A lot of people are talking about location-based games. We actually just wanted to be able to race NFS in our hometown. We also wanted like really hyper-local leaderboards and needed to get access to that raw data, and wanted some of the gameplay that you were going to be having on mobile to be responsive to place. So this isn't, don't get me wrong, like the stuff that it's still really important to control the design and look and feel of the map and make that part of your game and have access to those kind of low-level tools. But what I want to spend a little time today talking about is how important it is to access the raw data, right? The map itself, the visual part of the map, is starting to just be the canvas where so much of the gameplay and the game logic can be designed from having access to this raw data. So I want to speak a little to that. But first, I thought it would be important to explain the perspective that we're coming from. Most importantly, we're not a gaming company. We're a map company. And we not only have these amazing sets of streets and buildings and terrain and imagery for every place in the world, but we make it easy to then publish that imagery into a mobile. So everything we build at Mapbox is for developers. And then developers have that SDK as part of their application, and as their users start using it, the map actually gets better, right? Through anonymized, aggregated data. It's almost, think about it like kind of like Waze, but in the term of gameplay, is coming back for latitude, longitude, and helping make a better map. And then your users are getting that better map back in real time. And that's what's allowed us. And you're going to see some of the breakdown of data in a second, but this is what allows us to be making a true live map of the world in real time. Like, for example, say you're trying to figure out if you want to have certain gameplay go on in a park, right? So we're talking to a studio that's looking to do something more in the AR space, and they wanted to be able to crash a spaceship, right? And it turns out they have different size spaceships. How do you know where to put one in the city? Right? How do you make a custom? How do you assess where points of interest should be for gameplay? How big are these ships? Where are the parks? Can you get access to that raw data? What's the size of the park? How do you crash the ship so that literally as you're walking down a trail in the park, do you know where the foot trails are in the park? To make sure that as you approach, you actually get to see the door opening, right? Like, turns out so much of the gameplay and the strategy can be designed through the raw data itself, and that's what we wanted. That's what we wanted to expose, and we're continuously enriching that. So, again, in regards to not being a gaming company, this is map data used to help you explore a city with Nat Geo, or track an event on CNN. If you're booking a place on the other side of the world with Airbnb, those are going to be our maps. Or when you wake up in the morning and you want to be able to look at the weather, right? Weather.com. Every time you see the Weather Channel's logo, we've told you where you are. Literally hundreds of billions of requests a year. So we took a lot of this map data that we've been making on the mobile side, and again, not a gaming company, but the reality is a lot of games were looking to use us. And so you look at Battlefield 4. You want to have a leaderboard that was a local, right? And being able to have a cool themed out map using our Photoshop for Maps tool, you could go in and make that. Or the new Mind War game that's coming out, where you're a spy. It's a post-Orwellian government, and literally you're being guided by GPS in the real city, listening to cues from another secret agent of what to actually do in the city. And again, being able to have access to that to this data is what's going to make this possible. Or fighting zombies. This is, I think, from 2013. You start with a butter knife, and you can build up your skill set from there. Point is, we had a lot of game developers wanting to do more with maps, and it was really hard. So I want to spend some time talking about the data that we're exposing here, and how you can access that data. So you saw that not only as people move, you can start identifying not only footpaths and bike paths and streets of where people are driving, but then you also start knowing, like, wait, when's a popular time to be in a park? When should I actually have certain gameplay happen in that area? So being able to get access to the raw streets and places is essential for creating a more gameplay design, but then also terrain. I want to show you this in a minute, specifically some of the examples with the Mantle plugin. And then lastly, imagery, right? So no matter how you want to design the actual map, you can pull in all of this. So most importantly, when you're adding a map, the main thing is to think about the map can be anything. No matter what kind of design for different levels or whatnot, you have full control over that using our studio, and can just make it seamlessly integrated. But it's not just, like I said, it's not just the streets. It's not just having a kind of traditional design map. Being able to bring in live imagery, and there's some amazing examples I think we'll be sharing next week of what it's looked like. Imagery from satellites of the Grand Canyon that's just draped over into the canyon, and being able to bring that directly into the game. So most importantly, it's being able to have all of this in different layers. So our terrain mesh exposes the elevation on a super granular level. So maybe you want a point of interest if you're building more of an activity game where the goal is to get to the highest point in the city for a lookout. So being able to access the raw data pieces. Or let me actually show you what this looks like. So when you pull down maps from your Mapbox account into Unity, you're getting every single detail in the map available to query, to style, to make part of the experience. Whether that's bridges, 2 parks, 2 streets, literally being able to know the directionality, all of that is exposed to you through the game, and then not only through gameplay, but then also through design, right? That becomes the scaffolding to design and make your map, and again, not just streets. So land use, right? Being able to show rugged terrain, then being able to do things like manipulate it using weather data depending on the real-time environment, and theme that. So by exposing the raw map data directly to the developer, you can make these custom maps and then combine it, right? Take that elevation model, take the full DEM, and lay it over with satellite imagery to start making a true 3D model at a certain pitch. The high fidelity of the data is super important. Again, this is our terrain map, and being able to manipulate this however you want. So whether you're trying to bring in a real world game environment, or whether you're trying to take real world assets to make a totally fake world, or whether you're trying to use the map data ahead of time as you're prototyping the strategy and the interaction of the game, or whether you're trying to have the raw data accessible for interaction once you're playing, we want to expose all those layers. So it's not just about content. In addition to content, it's about scaling that content. Each month we have about 250 million users, end users hitting us. All of our infrastructure is powered on AWS. We started working on AWS in 2006. We're in every single every single region. In each region, we're operating under multiple availability zones. So our server logs kind of look like the world's respiratory system. The most interesting addition to this map is China. How many people in the room have end users in China? All right, a couple hands. We're not the only mapping company in the world that hosts both international coverage and local coverage in China. We're the only company that also has a Photoshop for maps to be able to go in and style and design that. So if anybody wants to talk specifically about China, and especially after some of the regulations put in place beginning of July, requiring sign-off on mobile games, and one of those factors of sign-off are legal maps, I'm happy to talk through that. It's a really exciting market, and being able to make sure that those maps are super fast in country, but also super fast when you're traveling. The number that just blew my mind this year is I heard that 120 million Chinese were traveling abroad last year, and that number is supposed to grow upwards of 240 million by the end of 2020. So again, not just getting you started with maps quickly as you start building the game, but then as your game becomes successful, being able to scale all of that so you don't have to think about performance issues. So most importantly, I want to talk about our fully native C# SDK. This week we are opening up that for developer previews. Anybody that's interested, would love to have you sign up and get you early access and talk about that. I wanted to actually show how this works. So, at the very least, it's about being able to just put a map into your app quickly. And again, you can, as you saw through the various designs of the map, you can change the look and feel of the map however you want. The key part here is providing really low-level access to our APIs, but directly in Unity. So being able to go into your assets folder, go into the project file, and drop in a couple lines of code. And hey, look, maybe you don't want to show just a streets map. Maybe you want to show a satellite map. And OK, let's go zoom it down into San Francisco and hit save. Right? And then, OK, why would you want to, maybe you don't want to actually set where you want the zoom in to start. Why don't we just go over here, and since it's going to be a mobile game, let's have it actually follow where you are. And providing this really low level of data is, and access to that data is important. I think it's also really important, going back to the different layers that we provide, making it possible for you to manipulate anything you see in the map by bringing in these vector tiles and accessing every single detail. It's not just about being able to manipulate this on the design layer, but it's also about being able to have gameplay. When you walk into a park, this experience is going to change. When you're moving at this speed, this experience is going to change. When, as you saw in the earlier slide, no, when I get close to Blue Bottle, I want to have interaction like this. And I think we're about to see some much higher end, higher reward ad play, especially as location gaming comes more into more mainstream. And we want to be able to make sure that both ad networks and the developers themselves can create a more intuitive feel on the ad side to make sure that it feels really authentic and doesn't just generate on the revenue side, but encourages more usage of the game itself. So it's not just about, our SDK is not just about exposing this to Mantle, it's also about, to Unity, it's also about exposing this to other plugins. And I hope some folks in the room got to see Dean's presentation earlier this morning on Mantle, and it's gorgeous. What you're able to do, literally copying and pasting your Mapbox URL, and then being able to expose the terrain layer here and add procedural context, whether you're putting buildings on like this, or a certain kind of grass pattern, or crazy ass mushrooms. The point is, the SDK is just a way for Mapbox to expose this data, and to let your designers design their own world, and to let the strategy pod and your creatives make really intuitive gameplay here. Last thing I want to mention is while we're showing some code on the screen, which can often be intimidating at first, being able to have a prefab here, we can literally drag and drop the map right into your app. So if you want to be able to create a basic leaderboard, or you want to be able to actually just show where players are, we want to make that super easy. So on one hand, I really love talking about the strategy of play of what you can do and exposing these raw sets of data. But it's also just really important to be able to put a basic map inside your application and have it look great. So, for us, this is exciting change going on here, right? We were never able to access the raw map before, and we always think about designing a level in a certain confined environment, and our goal is by exposing the raw parts of the data to the developer, that the level itself starts being a mirror of the real world and letting you create much more unique experiences. So I encourage you all to go to mapbox.com /Unity. Let us know if you want to be part of the early access program, and we'll get you signed up quickly. But let me stop there and answer any questions. We've got a bunch of the folks that built out the SDK and expose these API endpoints here. I see Dean from Mantles back here too, and I have a mic, so I'm happy to pass it back to folks that are working on specific engineering functionality here. But hand it back.
Can you talk about the cost of the service?
Say that one more time. Pricing, yeah. So most importantly, it's free. We charge per monthly active users. So up to 200,000 monthly active users, it's free. And then we have a $500 plan that gets you up to $1 million. And then as you go above that, we basically charge for that. So you can just literally go to mapbox.com, click sign up, get your API key, and that API key allows you to start using our design tools. And then you grab the API key and drop it into the SDK. So, any other questions on pricing while it's out there? Yeah. So right now we are not counting them as just paid users. If that's your question, it's just any user. Our interests in the way we're mapping. The way we're associating pricing to the gaming space is exactly the same as we associate pricing on the mobile space right now. And what we wanted to do was to not tie it to usage. So on the web, when we charge, it's always for like number of map views. When you're doing anything location on mobile, you're using the heck out of the map. And we want you to have that map like totally full screen, no matter how much people are using it, how much people are walking with it. So that's why we did the monthly active point. And we also built up the raw tech to do a level of caching so that the maps work. Not only you can download and do offline. So for example, if you install Lonely Planet, you can literally go download a guidebook, and that whole map rendering out in GL at 60 frames a second is going to work without internet connection. But you can also lazily load. So as you open up a place looking for coffee, and then you drop down into the subway, that map's still going to locally cache. And so we built a lot of the tech, not just for a better user experience, but then also to reduce our costs, so thus allowing basically flat pricing. And then lastly, on the car side, cars are cars. We charge per model. So that's how we think about pricing in general. How this will ultimately play out on the game side, especially given some of the interesting usage curves that happen. We're not entirely sure if this is going to be the best, and we're super keen to work with folks to craft something that makes sense. At this point, given how much traffic we do, we have a really good sense of where our costs are. And our interests are to create a pricing model that works in a way that causes you to not have to think about this. So, any other questions on pricing? Any question right there?
So I've got two questions. The first is about caching.
Mm-hmm.
Talk a little bit about caching. Can you give us a feel for what is the mechanism for caching tiles of the map, what the size is going to be for a mobile application?
Yeah. So the first question is about caching and what the size looks like. So a lot of folks we've been talking to over the last couple months as we've been building out the SDK. Many folks are new to maps, so let me just be egregiously basic. When you open up a map and you see the little squares load, those are map tiles, right? Up until recently, those used to be actually raster images, right? The neat part about what we're exposing outside of satellite imagery is still a raster image, right? But the actual map is being exposed as vector tiles, which ensures that the map is being rendered on device. So that means that once you open up a map, you can set your cache config in the app for however long you want. You can either do it per amount of space, number of tiles, and you can look at the cache headings, right? Because again, the map's always updating. And for some people that just want to have a basic leaderboard, look, you don't care if new streets are added, so boom, set the cache header. You can ignore the cache headers and say, hey, here's how long I'm going to cache it for. But the neat part is, even though it's like cached, because you have access to the vector tiles and all of these layers exposed, you can still manipulate the map itself. So as you move from a daytime mode into a nighttime mode, or as you move to a new level and parts of the city need to go away, or you want to add in your own custom data. So say you want to be able, again, post-apocalyptic, you want to have certain areas have been affected by a nuclear winter coming in, you can upload your own vector data, like your own areas that you want to expose, and have that then manipulate the map data underneath. So in these areas around San Francisco, where you drew a line saying, in level 4, here's what's going to happen. The nuclear plant melts down, the cloud spreads over here. Next thing you know, the map that starts getting rendered is like all melted and messed up. Or you can start programmatically doing that. We've been doing a lot of work with IBM and the Weather Channel, and one of the things they want to do is like, how could we actually make in-app purchases more relevant based on real-world environment? Like, are people going to want to be able to have experience that, when it's cloudy and rainy in San Francisco, the gameplay is going to change? And because you can suck in certain live data that affects our vector tiles, whether they're cached or not. So any other questions on caching or offline use?
You're actually heading in the same direction. So the idea is that we update the map tiles and send them to Mapbox and not to our own servers.
Yeah, great question. So the question is, where do the maps come from? And two, if you're adding custom data, where is that stored? So a couple answers to that. One, all map data is streaming down directly from our global infrastructure at Mapbox. So whether you're cache, and if you cache that, obviously you're then just pulling it locally. With your Mapbox account, you are able to upload custom sets of data, and we have some people making some pretty funky worlds. We also have, architects and historians uploading. And one of the most exciting maps I saw was Boston over the last 200 years. I had no idea that the main part of Boston was basically like an island, and then they want to actually show how it grows and the land changes and stuff like that. They literally just uploaded GeoJSON files of the area that they digitized off old maps. So if you want to go to a gameplay of like the 1920s in New York, think about how that changed. Or like, there's a lot of spaces in this world in this country that have radically changed recently. And so your ability to bring in old maps or old context and then have that vector data become part of your base map and expose that both to the design side, but then also to the gameplay side. So you would upload those to Mapbox. And what we do with that data is not just that you're uploading data. We're turning that data into vector tiles on the fly, not just using our global infrastructure to serve it out, but then we're also doing tile optimization. So think about a geometry of an area, okay? The more points you have to make that geometry, the smoother it is. And you want something super smooth, especially when you're going to be rendering out at 60 frames per second. But by definition, the more points you're putting on, the larger tiles you're having. What we actually do, we will do radical simplification of that geometry to compress the actual vector tiles so that what you're streaming down the mobile is super fast. And you can even make it so that depending on what style sheet you're using, we will only send the vector tiles, the vector data in the tile associated to that style sheet. For example, say you want to go design just a general map of New York, but you don't want to have buildings. Buildings are inherently a lot of polygons, that's going to weigh a lot. But you don't need it for your gameplay, right? Okay, well, we're not going to send them to you. So all that kind of optimization, because every single second of the render matters on the device, and we've been optimizing that. What other follow-up questions do you have on? Any other questions in regards to offline caching? Right.
What about building data? What kind of building data do you have?
Yeah.
And what about weather data and other things that can augment the map?
So the question is, what kind of building data do we have, and then what other sets of data do we have that we can expose to start augmenting not only the map but also gameplay, right? We have one of the largest sets of 3D building data in the world. And the way we make Mapbox maps isn't just through all this little micro anonymized probe data of people using our app, but it's also through open communities. And we do a lot of work with OpenStreetMap. And being able to pull in these sets of buildings, I think New York is 1 million buildings, in San Francisco something like 850,000. So on a city by city level, being able to have these super detailed polygons and render those in 3D. But you can also upload your own. So we have certain drone companies uploading point clouds that are then rendering their own areas and stuff like that. Last question was what other data do we put out? We don't do anything with weather data. We have other partners that do stuff with that. Forecast.io from the Dark Sky guys are great, but also the Weather Channel's main API. Surface textures, we don't have any of those. You would pull those from the asset store if you wanted to associate them or make your own. But what's cool is to the design studio, you can upload your own SVGs and then apply that kind of SVG texture to a certain data type in the vector file.
I'm asking about capturing surface textures of buildings like you see.
Yeah, great question. Okay, so what surface texture buildings do we know about? In the data, officially none. Via our satellite imagery, a lot. We have not gone the step of analyzing our satellite imagery to start extracting out the actual real building patterns, which I think is what you're getting at. Yes. Yeah, and the neat part is if you source, so there are providers that provide that level of custom data. Any custom data that you source, you can upload through an encryption connection to an encrypted store on Mapbox. So any proprietary data you're either making or buying that you want to turn into vector tiles, you can, and then pull that down. For example, like Sanborn on the flyover side has some really exciting 3D buildings they've uploaded and whatnot. So the question is, how do you verify player location, or do you just use client trust? No, you can totally spoof player location, just like you can in Pokemon. So that's all happening on the mobile phone. As you saw through this example, literally we're just pulling the basic Unity call up to where the player is located. So the same problems that with the cheating on Pokemon and spoofing, you would have to build that into your app. Is that what you're getting at? Okay. Other questions? In the back? Yeah. So the question is resolution of satellite imagery and resolution of terrain data. So we have a full terrain model for the entire world, 1 meter in the US, 5 meters Spain, 10 meter Norway. Totally depends on the country. All across Africa is mostly 30 meters. We'll take the shuttle radar topography mission, this open data from the US government, and we turn that into like these this whole grid of data. But then we're updating on a country by country basis. Sometimes we buy data from different organizations. Other times we pull it from open data. On the satellite side, I think we're pulling right now or imagery side, we're pulling right now from 27 sources. Camilla, who runs the satellite program, is actually right here. Our largest buyer is from Digital Globe, which is the largest satellite company in the world, which is 30 centimeter resolution. That means each pixel is 30 centimeters. And so depending on a city coverage, we even have some 10 centimeter coverage in certain cities that we fly. So it totally depends on where the map is, but it also depends on the refresh rate. So last year we did the largest high resolution satellite buy in history with DG. This is something we're doing annual refreshes on that happen dynamically. Any other questions? Yeah. Sorry. Mm-hmm.
Like building plugins.
Yeah.
Post on Reddit, like a one-to-one whole area. You building but Watch Dogs 2 is all professional artists.
Yeah.
So
Yeah, good. So the question is, in addition to just roads and buildings, like, do you have more accurate information on that? The honest part is it totally depends. So you have certain cities, like New York and Washington, D.C. I think the New York Census, the New York Tree Census has added like 580,000 trees to OpenStreetMap, so you know the exact points of where all the real trees are. Some cities have actual streetlight locations, and they'll even add metadata descriptions to the streetlights. So when you go up to Vancouver and you're in Gastown, you're actually seeing like the old gas lights, and you can do some theming on that. Our interests are to expose as much of that metadata as possible in the vector tiles. Does that answer your question?
Enough people have done these in certain areas that if you had to do your own manual data collection, you could put them in the same format. People are using it like a certain category defined.
Yeah, so the question is, how could you then augment a certain area for where we don't have coverage? There are two ways. One, a great place to go is OpenStreetMap as a community to add data, but we have a lot of people that want to be able to make custom data and have that be owned as a proprietary asset. And so in that case, you could make your own data file and then upload that to your secure Mapbox account and then just pull that down via vector tiles. So whether you want to do an open data push or work with an open data community or own and have your own data, it doesn't matter.
Last question, has anybody done photogrammetry style texturing on top of the building models that you provide?
Yeah, so the question is photogrammetry style texturing on top of the models. I should have totally added in the Grand Canyon slide. I'm happy to show you something after. If anybody else is interested in a photogrammetry analysis and some of what we're doing with imagery and combining that with elevation models, would love to talk. Camilla is probably going to be one of the best people to show that off, but CU is also here and whatnot. Any other questions? Cool. There's one more back there, and then let's wrap up. Last one.
Do you guys provide waypoint data or any kind of for direction finding navigation? Also,
Yeah, great question. So do we provide any kind of direction navigation data? In addition, the SDK provides full access to all of Mapbox APIs. So it's not just being able to add a map in there. You can also add search, and you can also add directions. And those directions are about to have real-time traffic. So we're really excited to see what people can start playing with that. And all of that's documented in the C# SDK. So happy to expose, talk about ways you can get access to those APIs. But listen, let me wrap up here. Thank you so much. I'll be outside right after if anybody else has follow-up questions. Cheers.